Okay, so we're going to be solving another question from the second chapter of the engineering mechanics. And we have the force F that is acting along the line MA. And we know M is the midpoint of the radius along the x-axis. And we need to determine the equivalent force coupled system at point O when the angle theta in the figure is 40 degrees. Meaning we need a force and a couple at the end of this question. We know already the only force that we have in here is the force F. So for the force part of the force couple system, we basically have the force F, which makes this angle here, which is this angle. In here, we can call this angle alpha. And this will be our radius. We know M is in the middle. And I'm going to solve this using trigonometry. And if we look at this triangle that we have, basically, if we use the law of cosines, so we're going to use the law of cosine to figure out the AM side of this right triangle. So AM squared is equal to R squared plus OM, which is R divided by 2 minus 2R times R divided by 2 cosine of theta, which from the question we know is 40 degrees. And now this is going to give us the AM. So we have R squared plus R squared divided by 4. These two will be cancelled out, minus R squared. And sorry, we have a cosine of 40 degrees in here. I'm just gonna clean this up. So our AM in here would be basically, we can just factor R2 in here. So it's gonna be 1 plus 1/4 minus cosine of 40 degrees. And this is gonna give us the AM. Again, we have AM squared in each of these sides. So we basically have the square root of 1 plus 1/4 is 5/4 minus cosine of 40 degrees. And we can take out the R, so we just have to figure out this value. So the square root of 5 divided by 4 minus cosine of 40 degrees. And our AM in here would be 0.696 R. All right, now the angle that we are looking in here for F for the force part is the angle alpha. So if we just call this angle here maybe beta, we know alpha plus beta is 180. Since it's a straight line, so it will be 180 degrees. And for finding the beta, we're just going to use the law of sines. And since we're interested in beta in here, so we have sine of beta over R. And the angle that we have as a given is theta, so sine of theta, which is 40 over AM. And our AM, we figured it's 0.696 R. So we can cancel out all the R's in here, and beta would be sine inverse of sine of 40 degrees divided by 0.696. So let's just figure out the beta in here. So basically 180 minus sine inverse of sine of 40 divided by 0.696. And we know this value that we have, first of all, our beta has to be an angle more than 90 degrees. And we know sine of 67.45 degrees is equal to sine of 180 minus this. But we are looking for the angle, since we can see that this angle is more than 90 degrees. So we're going to go with the angle between 90 and 180 degrees. We know sine of one angle in the first and second quarter is both positive. So actually in here, we're going to get two answers. And the second one is actually the one that we're looking for. So our beta would be basically 180 minus this answer. So the beta in here would be 112.55 degrees. And now we can find alpha. Obviously, alpha would be 180 minus this, because we figured that alpha plus beta is 180. So the 67 that we found in here would be our alpha. So now we have the angle for the F. This is actually 67.45 degrees. And now we have to find the moment For finding the moment, the easier point, let's just clean up the figure. So if we go with the line of action, this would be our easiest vector that we have. And if we resolve this force into two different components, we can see that this one won't make any moment because it will pass us through O. So we only have the vertical component along y-axis, which would be basically f sine of alpha, and this distance is r divided by 2, and that's how we find the moment. And we can see the moment is a counterclockwise moment, so positive. MO will be positive. The force F sine of the angle alpha, which was 67.45 degrees, times distance was r divided by 2, and our moment would be basically sine of 67.45 divided by 2, so 0.462 r, and we always consider counterclockwise positive, so the moment will be counterclockwise. And if we just want to show the final answer, our force coupled system, the force would be the force that makes angle alpha, which was 67.45 degrees, and the moment about O is 0.462. I forgot the F in here, so F times R, and the moment is counterclockwise. So yeah, I hope everything was clear. Let me know if you guys have any questions. You guys take care. I'll see you in the next video. Have a good one.